All right, hello. Welcome to the second day of graphing. So there are many things we can do when graphing reciprocal functions. You can read through those on your own. We don't need to read through them for the video. But today we're going to be working with the equation 2x squared minus 7x minus 15 over x squared minus 4x minus 5. And we want to write the characteristics. Then we will graph, and then we'll find our intervals. Okay, so the first thing we need to do is simplify the equation. So we have 2x squared minus 7x minus 15 over x squared minus 4x minus 5. Okay, in the numerator, we have a complex factoring quadratic equation, and I don't need to go through all of that, all the steps, but when we factor the numerator, we will get 2x plus 3 and x minus 5. And when we factor the simple quadratic equation of the denominator, we get x plus 1, x minus 5. Okay, we see a common factor on the numerator and the denominator, so let's get rid of that, creating a whole. And our simplified expression is 2x plus 3 over x plus 1. Okay, so from there, we can see that we have a whole, so let's work with the whole, and the whole is at 5. So in order to find the y coordinate of this whole, we have to plug 5 into the simplified version of the equation. So we have 2 times 5 plus 3 over 5 plus 1, and we get 13 over 6. Okay, so our whole is 5 and 13 over 6. Okay, other things that we can find from here, we need a vertical asymptote, which is the factor of the denominator. We only have one factor, it's x plus 1. So the vertical asymptote occurs at x equals negative 1. Okay, the horizontal asymptote occurs when dividing the leading coefficients. So we have a 2 as a leading coefficient in the numerator, a 1 as a leading coefficient in the denominator. So the horizontal asymptote occurs at y equals 2. Okay, let's go green for x-intercept. The x-intercept is the factor of the numerator, which was 2x plus 3. So that means the x-intercept occurs at negative 3 over 2. And then we have a y-intercept. So if I write the simplified version, 2x plus 3 over x plus 1. So y-intercept occurs when the x's are 0, so all that's left over is the division of the constants. So y is 3. Okay, before we worry about all the characteristics, we're going to graph. So I'm going to try, I'm just going to guess that it's not quite center. Off by 1 in each guess. Okay, if we plug in what we know. So we have a vertical asymptote in purple at negative 1. So here's our vertical asymptote. We have a horizontal asymptote, black to blue, at positive 2. Okay, that's a horizontal asymptote. We have a green x-intercept at negative 1.5. Right about there. Okay, Clearly I can't do the y-intercept in black, but we have a y-intercept at +3. Okay, and we have a hole at 5 and 13/6, which is just over 2. So if we go over to 5, here's 5 here, just over 2. We're going to make it a little clearer. We're going to have a hole. Okay, from there, what we see to the right of the vertical asymptote, our equation is going to be in the top right. Okay, we know this by the y-intercept and the hole. Okay, so it's going to approach the hole, make a hole, and then continue on afterwards. And then based on our x-intercept to the left of the vertical asymptote, we will be in the bottom left quadrant. Okay, now let's write our characteristics. So starting with domain, we know that because it includes decimals, we have to write XER, and we know that X cannot be -1 for the vertical asymptote or 5 for the hole. Okay, the x-intercept we found out to be -3/2, so we write it as a coordinate. The y-intercept we found out to be +3, so we write it as a coordinate. The asymptotes, the vertical asymptote occurred at x equals -1. The horizontal asymptote occurred at y equals 2. Okay, so now we deal with the end behaviors. The first one we want to work with is when the vertical asymptote is at -1. Okay, so as we approach, so as x approaches -1 from the left, so that's what we're doing. Okay, so in red, as we approach from the left, you can see at the bottom that the line is going down and to the right. So as x approaches -1 from the left, y approaches -infinity, down and to the left. As x approaches -1 from the right, okay, so up here, what's it doing as it goes this way, it's going up. Okay, so as it approaches from the right, y approaches +infinity. Okay, now the horizontal asymptote at y equals 2. As x approaches -infinity, actually, I'm going to do this in blue so we can draw an arrow. Let's do it in green. As x approaches -infinity, okay, so as the x's are going this way, the line is getting bigger towards 2. So it's going towards 2 from the bottom. So as x approaches -infinity, y approaches 2 from the bottom. As x approaches +infinity, okay, so if we go back down, as x approaches +infinity, we see that it's approaching +2 from the top. So 2+ means approaching from the top. Okay, last thing we need here are the positive intervals. So starting left to right, we can see that it's positive all the way from negative infinity until we get to this x-intercept. Okay, so it's positive from negative infinity to our x-intercept at negative 3 over 2. And then again, it's positive after the vertical asymptote, so negative 1, all the way to positive infinity. So it stays positive after, to the right of the vertical asymptote. Okay, the negative interval, well, the only thing that's left is from negative 3 over 2 to the vertical asymptote, so the only times it's negative are from the x-intercept to the vertical asymptote. Okay, if we look at the two lines on our graph in red, both to the left of the vertical asymptote and to the right of the vertical asymptote are going down to the right as we move right. So there are no increasing intervals. Okay, and then decreasing, so it's decreasing from negative infinity to negative 1, and from negative 1 to positive infinity. Okay, we don't have to worry about writing the whole in there. Thank you.